All right, Honors Algebra 2, welcome to your 1.5 video, section 1.5 video, in your 1.4 to 1.6 game plan. We are on page 6 in this game plan. We're starting to get a little real. Graph each solution set on a numbered line. I put these in a nice order, I do believe. First one is x greater than or equal to 5. The mouth goes towards the bigger quantity, greater than or equal to, because you have equality. Here's what you do. 5 is to the right of 0. Closed circle, you're going to shade to the right. Okay, then on B here, x greater than or equal to -2. Here's -2. Greater than or equal to, shade to the right. Then on C, x is less than or equal to 4. These are all the equality ones. Less than or equal to 4. So 4 is greater than or equal to x, or x is less than or equal to 4. Close circle. Shade to the left. All right. Then we should practice doing this. Then on D, let's see if this goes a little better on D. X is less than or equal to -3. There's -3. Close it up. Shade to the left. Less than or equal to -3. All right. E, F, G, and H. We have no equality now. We have no equality, okay? So on E, can you see? What am I doing? There you go. I can't even see. There's E. X is greater than 5. There's a 5 open circle because there's no equality. Again, skip this at the beginning. You have open versus closed circle. Closed circle for equality. Open circle if there's no equality. So open circle there. X is greater than 5. So let's look at G. You can see G right there. X is less than 7. Here's 7. Okay, you don't have to, make 6 ticks before 7. You can just say 7 is to the right of 0. Open circle because it's less than. Shade to the left. X is less than 7. F. X is greater than -1. So there's -1. Greater than, open circle. Greater than means shade to the right. H. X is less than -4. Here's -4. Open circle because there's no equality. Less than means you shade to the left. Okay, so those are all pretty easy. That's how you shade, and that's what we'll do for the next several pages. Go to the next page here. And on the next page, we are going to do we're going to do the first 4. Okay, so these are pretty easy. I want to do the first 4 with you in this notes section. Y minus 7 is less than 4. You're going to solve it like you would do a regular equation. Move that 7 over. So now you have y is less than 11. Here's 11. Open circle, because there's no equality. Less than means you shade to the left. Y is less than 11. All right. On to here. We are going to subtract 4w. I'm going to put all the w's on the side with the bigger w. 5 is bigger than 4. So w plus 3 is greater than 9 minus 3. W is greater than 6. Okay, there's 6 greater than means open circle. And you're going to shade to the right. W is greater than 6. Let's talk about 3 and 4, but you know what? 4 is looking at us right now, so let's do 4 first. All right, that is a -1x, so be careful. I'm going to subtract 14 from both sides. -1x is greater than -22. I'm going to divide by a -1. Now be very careful. So first off, I know it's x. I know it's 22. Let's back up here. Here's a fact. 10 is greater than -2. I don't think anyone would dispute that. But when I multiply both sides by -1 or divide by -1, like I literally did here, now I have -10 and 2. And -10 is not greater than 2. So this reinforces the rule you know from Algebra 1. If you multiply or divide an inequality by negative, the sign has got to flip to keep a true statement. So x is now less than. You got to flip it good, less than 22. There's 22. Shade to the left. All right. Let's talk about 3 on this page. Then we shall move on. Next page we'll do 2 of them. So on 3 here, where's 3? There's 3. All right, I'm going to subtract 3x. 2x minus 3 greater than or equal to 11. Add 3 to both sides. 2x greater than or equal to 14. Divide by 2. X is greater than or equal to 7. Where's 7? There is 7. Close that circle, shade to the right. All right, so we'll do some of the more interesting ones on Monday and Tuesday, I would believe. Let's go to the next page and let's look at 9 and 10. So that is it with the graphing part there. Examples continue. Let's look at 9. Now I'm just solving. You probably can't see 9. Great. There's 9 a little bit better. I'm going to multiply both sides by 5. 5x greater than or equal to x plus 6. Subtract x from both sides. Now it's 4x greater than or equal to 6. Divide both sides by 4. Well, 6 over 4 is 3 over 2. All right. That's pretty much how you do number 12 there. Be careful. You will have to divide by negative unless you really flip things around. But be careful on 12. We'll probably talk about 12 next week. Won't leave you hanging on 12. Let's talk about 10. Okay, on 10, I recommend, just like we did on this last one, let's multiply everything by 4. Okay. 4's cancel. 2x minus 9 less than or equal to 4x plus 8. Subtract -9 less than or equal to 2x plus 8. Subtract from 8 both sides. -17 less than or equal to 2x. And divide both sides by 2. Now, because I'm not graphing, you can definitely leave your answer like that. -17 over 2 is less than or equal to x, or x is greater than or equal to -17 over 2, which is -8.5. And that is page 8, and that was great, dare I say. Let's go to the next page, 9 here in the hashtag game time section. I think it's a good idea to look at 2 and then 4. So on 2 there, I'm going to add 14 to both sides. Now I do have to graph as well. So -6 greater than -18. I'm going to divide by -6. -18 divided by -6 is 3. Oh, and again, you flip the sign. When you divide or multiply by an inequality, you got to flip that sign. X is less than 3. There is 3. Less than means open circle because there's no equality. And then I shade to the left. All right, number 4. Let's do 4 on this page. Number 4. And going to distributes there. Can you see that? Maybe need to bring this down a little. Let's try that again. Distributes. -16 greater than or equal to 10x minus 55. You got to graph this one. Ooh. Add 55 to both sides. You have 39 greater than or equal to 10x. You're going to divide by 10. That is 3.9 is greater than or equal to x, or x is less than or equal to 3.9. This little alligator here wants to eat the more muscular friend here. So that could be you. You tell your friend, hey, let's switch sides here, but the gator's not fooled. It's still going to follow you, okay? X is less than or equal to 3.9. There's 3.9, or 39 over 10 Close that circle, shade to the left. Close circle because you have equality, shade it to the left. All right, we're going to go here to page 10, and to finish this section off, we're going to do 9, 11, and 12. On 9, 11, and 12, there is no graphing. There is just solving. On 9, going to get that 18 to the other side. 9x plus 5 over 4 is less than 8. Going to multiply both sides by 4. 9x plus 5 is less than 32. Going to subtract 5 from both sides and divide by 9. X is less than 3. Number 11, so 10's an interesting one. Look at that, we'll do that one in class. Let's take a look at 11 here. 11 is doable for us for sure. On 11 here, I'm gonna move the 4x over because 10 is bigger than 4. So left side's aside for my x's, then I'm gonna add 6 to both sides. And then I'm going to divide by 6. All right, x is less than or equal to 8. And in this section, the final one here is number 12. Number 12, there's 12. I'm going to multiply both sides by 8. 8x is greater than negative 3x minus 15 because those 8's cancel. Add 3x to both sides. Add that 3x over. So that arrow means I'm moving it over. 11x is greater than negative 15. I'm going to divide by 11. Negative 15 over 11 is a good answer. Negative 1 and 11/4, negative 1.36. Repeating. Now, here's what I think we should do, honestly, so we can make some quick progress. Preview to section 1.6, and we were doing this in calculus the other day. Preview to 1.6 here, and honestly, preview to pre-calculus and calculus. So page 11, this is all going to be in a video. Write each inequality using interval notation. Interval notation, what do you mean? So this is set notation. Okay, what we're doing, this means x such that x is less than or equal to negative 3. X can be anything as long as it's less than or equal to negative 3. Less than or equal to negative 3 means negative 3 is the highest number it can be. We go low to high. Negative infinity is the highest number it can be. Because we have equality, we use a bracket. Brackets are for inclusion when we see an equality part. Now, x can be anything up to negative 3 and less. Well, the smallest thing we can imagine is negative infinity. X can be anything from negative infinity to negative 3. Now, negative infinity is just something we can approach but never hits. So there's always a parenthesis around negative 3 because a parenthesis means does not include. So we do not include negative infinity. So no equality part there, does not include. That is interval notation. So x can be any number from negative infinity to negative 3, including negative 3, not including negative 3. Now this is a new idea. I don't think you have to do anything really with it this year, but it is important to have this down. You will have to recall it in 2 years' time. So this is saying x is greater than negative 8. So negative 8 is the smallest it can be. Negative 8. Now there's no equality there, so I use a parenthesis around negative 8. Negative 8, too, can be anything bigger than negative 8. So it can be 10, it can be 100, it can be 1,000, it could be 1,000,000. It can go towards positive infinity. Again, I use a parenthesis there because x cannot be, it can only approach infinity. Okay, it can only approach infinity. Now, I'm going to do most of these. I'm going to maybe save a few of these for you for in class here. All right, so let's do 3. Let's do 3 and 6. So we'll save 4 and 5. Let's do 3 and 6. On 3, gonna save, gonna write down that we're saving 4 and 5. Gonna save 4 and 5 here. All right, so on 3, make sure that camera adjusts again. On 3, we got -3 to 8. So this is easy, low to high. X is allowed to be 8, equality, so we put a bracket around 8. X is not allowed to be -3, it has to be bigger than -3, so we use a parenthesis for that. We're going to save 4, and we'll save 5. 5 is not that hard, but we can do that one in class. And let's talk about 6. 6 is another in-betweener there. Between 2 and 17, x is allowed to be 2. You have equality. X is not allowed to be 2 or 17, so you put a parenthesis around it. That is interval notation. You're going to use that all the time in calculus. All right, well, let's do more of the interval notation. Let's talk about 7 right up there. Low to high. Closed circle means inclusion. Open circle means does not include. Take a look at number 9. -7 is the largest it can be. It can be -7 and everything less. -7 is the largest it can be. And then it's going to go to the left forever, approaching -infinity. -infinity, -7. Again, this is a little confusing now. It's all right. You just have to have it mastered in 2 years. Talk about number 8. So 5 is the smallest. It can be 5 all the way to the right. So 5 is the smallest. Now, it can't be 5. There's no equality. It's going all the way to infinity. It's going to approach infinity. 5 to infinity. Whoa, we're going to start 10. We're going to start 10, and we're going to leave 10 for when we speak again, Monday or Tuesday. Or, sometime else next week. We'll make sure to get that, though. Number 10. And then I'm going to graph it. So, -8 to 5. There is no bracket around each, so these are open circles. And a shade in between. Kind of looks like a dumbbell there. All right, and to conclude, number 12. -infinity to 4. That means 4 is the largest it can be. There's equality because you have a bracket, so close that circle. 4 is the largest it can be, so it can be 4 or less. That's how you would graph it. So that's an okay Honors Algebra 2 page there. Anyway, that is page 11, and that's where this video is going to end. And this is Yak Math Video signing out.